Shahabuddin, Asad Ehsan, Shalina Mehboob.
Assalamu alaikum everyone, I am Shalina Mehboob, and with me I have Asad Ehsan, Ismail Javed and Shahabuddin. The project that we will be presenting today is IoT-based refrigerator monitoring system. To walk you through the content of our presentation, it's going to start off with the background of the project and end up at the references.
Before we start with the technicalities of our project, let's discuss the market analysis of our project. So, in Pakistan, there are about 4 major ice cream players. Our project is based on commercial ice cream refrigerators. So, Walls, having the largest market share of 60%, we have approximated the revenue for ice cream generation. In Pakistan, annually about 150 million liters of ice cream is consumed. Per average, 1 liter of ice cream is about 350 to 400 rupees. So we calculated that annually about 50 to 60 billion rupees is generated from the ice cream industry.
Now this is the approximation of refrigerators provided by each of the companies in Pakistan, with Walls having the highest market share, provides the largest number of refrigerators, which lies around 30,000 to 40,000, followed by Umor, Hiko and Igloo. Now, if you were to estimate that 5 to 10% of the refrigerators were to break down, these companies are going to face losses in millions of PKR, with Walls facing the highest loss of around 350 million PKR.
In addition to that, if the refrigerators were to break down, the ice cream within the refrigerators would get spoiled, which adds up to the losses of each of the companies. So the total accumulated loss of Walls is going to be 500 million rupees if 10% of the refrigerators were to break down, and if 5% were to break down, it's going to be at about 300 million rupees. And for the rest of the company, it's showing the graph as follows for Omor, Hiko and Igloo.
Our project focuses on the problems that are faced by the ice cream companies in retail environment. We aim to optimize the supply chain management using modern technology. The problems that we are facing, number 1 is the asset misuse, which is the unauthorized relocation and misuse by the shop owners.
Second we have is the temperature disruptions. If the refrigerators are getting faulty, the temperature within the refrigerators is going to be disrupted, which results in spoilage of ice cream or lower shelf life.
The next one is supply chain disruptions, which is when the ineffective inventory management causes overstocking and stockouts.
The last issue that we are tackling is the compressor, the real-time maintenance. If the compressor breaks down, due to the lack of real-time tracking of the compressor health, it results in large amount of losses for the company. So that is one of the problems that we are facing as well. To back this claim, here is an estimate of calculations for 2 of the different possibilities that we have. 1, if the compressor were to break down, the company has to cover the cost for repairs, which costs about 35,000 to 123,000 per compressor. If the company were to follow preventive maintenance, which is the solution that we are proposing, it's going to cost the company about 9,000 to 22,000 rupees per compressor.
Now moving towards our proposed solutions. To address the problem of asset misuse, we have introduced real-time location tracking.
To address 2 of the problems, that was temperature disruption and compressor monitoring, we have compressor health monitoring for preventive maintenance.
To address the issue of supply chain disruptions, we have introduced product volume tracking to optimize supply chain management.
So let's dive into this section, literature review, that basically how research papers and different researchers support our project. So first of all, there are a lot of faults in compressor, but the most common and the prominent one is LRA, drop rotor impaired. So in this fault, basically the current consumption of compressor increases. An average current consumption of compressor is around 0.8 to 1 ampere. But when the current consumption of compressor fluctuates from this range, we can detect this fault. But obviously we have a lot of faults rather than this fault. For that detection, we have other parameters like temperature, vibration and voltage. So there is a limitation in this detection. So A cloud-based infrastructure is really important when you are basically doing the real-time monitoring, and we are doing the real-time monitoring of sensors in our project. So that's why cloud-based infrastructure is developed, which is on-made. But there are some limitations regarding the data transmission rate and you can say the scalability. So there are some issues regarding this. So let's discuss about the methodology of our project. First of all, we reviewed the problem, we came up with some solutions, and we reduced them to the efficient ones. Then we proposed or designed a system that was covering all the problems that we have discussed in the previous slides. So in the hardware implementation phase, we basically, you can say that we integrated all the sensors with the microcontroller. We tested them whether they are satisfying our requirements or not. And with the use of internet connectivity, we uploaded all the sensors data to the cloud. And on the cloud platform, obviously we are doing analysis, we are doing manipulation of data, and after that, we are transmitting data to the mobile app. For the future enhancements, we are implementing machine learning algorithms in two specific areas. First is supply chain management, and the second is compressors fault detection. So you can see the system flow diagram on the screen. So we have divided our sensors into particular areas. First is inside sensors, and the second is outside sensors. In the inside sensors, we have 3 ultrasonic sensors to measure the space inside the deep freezer, a temperature sensor to monitor the internal temperature, and the current sensor and GNSS. All these values are accumulating inside ESP32 microcontroller, and with the use of internet connectivity, it is uploading to the cloud. And after the analysis, we are transmitting data to the mobile app for user interface. So you are seeing the schematic of our project. On the right hand side, we have 3 ultrasonic sensors connectors, 1 current sensor, 1 temperature sensor, and 3 LEDs for data transmission, power, and any kind of fault. On the left hand side pictorial diagram, basically how we are integrating our sensors with the microcontroller. So right now you are seeing the 3D view of our PCB. It's a really compact 100 by 100 mm, and on the left hand side is a protective case, which is really compact 135 by 140 mm. We can place it behind the diffusers. So the main thing is basically how we are transmitting our data efficiently. First of all, we are using a cloud-based infrastructure named Kafka. And Kafka is used when you have to handle big data. So we are basically, using MQTT server as a bridge. It is taking values from microcontroller and uploading data to Kafka producer. After the manipulations and analysis of the data, we are taking data from Kafka consumer and uploading it to the mobile app. So it's really efficient, and that's how we are doing the data acquisition in our project. So for further details, I would like to call Shahab.
So this slide covers the comparative analysis of our component selection for this project. For the project, first of all, we have ultrasonic sensor. We have used JSN SR040. We have compared it with HC SR04, which are normally being used sensor in the market. We have selected JSN SR040 due to its better accuracy, and it provides waterproofing capabilities with the protection rating of IP66. Next, we have temperature sensor. We have used DS18P20 temperature sensor, as it is a digital temperature sensor and it is more accurate. Moreover, it also provides waterproofing capabilities as well as the protection rating of IP68. Both of these sensors, ultrasonic and temperature sensor, will be integrated inside the refrigerator. So that shows based on the harsh environment inside the refrigerator. Next, we have GPS module for GPS tracking. We have chosen Neo M8N over M6N due to its higher accuracy. All these components are selected for the reliability of our project in real world application. These are the system specifications, all the technical details of our project components and microcontroller. Now let's talk about the results. To sum up everything of our project, we have completed cloud integration using Kafka and MQTT Mosquito server. Next, app development. We have developed an application, mobile application to display all the sensor data on the mobile app. Next, hardware integration. We have successfully implemented all the sensors to our controller and got very excellent results. Future directions. So this project can excel to its best by following these future directions. We can implement AI models for supply chain management with ultrasonic sensor. We can also use AI models for better efficiency of compressor failures detection. These little changes can make our project more efficient and can address all these stocking issues in the market. These are the references of research papers and all the data sheets that we have included all the material from. And thank you very much.